Okay, so this video is going to do the introduction to the techniques of evaluating limits. Now, if I were you, I would actually do this lab after you watch the videos 1 and 2 for the notes. Okay, so the first way to evaluate limits, the first thing I want you to remember is that we only can evaluate using algebra is that you always substitute first. So whatever x is approaching, you substitute first, okay? And make sure you know what's going on. So here I'm approaching x is 4. If I plug a 4 in here, I get a 0. If I plug a 4 here, I get 16 minus 4 is 12 minus 12. So I get this indeterminate form, indeterminate form of 0 over 0, okay? Or plus and minus infinity over plus or minus infinity. Those are our indeterminate forms. When I get that, I check to see, wait a minute, is there some kind of algebra I can do this? And I'm looking, well, I'm going to see if I can factor. So I want you to make sure you write the word limit each time. And that's an M there. And I say as x approaches 4, then I want to see if you can factor the numerator. And when I factor the numerator, I see that it's x minus 4 times x plus 3 all over x minus 4. I'm going to put it in parentheses. Then I see that I can divide to make 1 or cancel. So I actually have the limit as x approaches 4 of x plus 3. Then I'm going to look and say, can I plug a 4 in there? As soon as I substitute the 4 in that spot, you don't have to write the word limit, so it is 7. So the limit is 7 when you plug a 4 in there. So that's our first technique. It's called the cancellation technique. Our second technique with algebra is also the cancellation, but now it's in the denominator. So I always have to do what Mrs. Pond said and substitute the -2 in there. If I do, I get the indeterminate form of 0. Plug a -2 in there, that's 4. Plus 6 is 10 minus 10 is 0. So I have my indeterminate form. So I always try that first. Then I say, is there some algebra I can do? Yes, I'm going to see if I can factor. So I write the limit as x approaches -2 of x plus 2, put in parentheses, all over x plus 2 times x minus 5. Now I can divide to make a 1 or cancel as you will. So I have the limit as x approaches -2 of 1 over x minus 5. Then I look and see, can I put in the -2? I can, so I don't have to write the word limit anymore. So the limit is -1/7. So these are some of my favorites to find the limit. You can just substitute first to get the indeterminate form and then look to see if there's some algebra that I can do. All right. Now, what if I get something like this where I've got a radical in there? So I look at it, and we have done rationalization before. And when we rationalize, it was usually in the denominator, but in this case, it was in the numerator. So when we rationalize, we use the conjugate, and we're going to do everything the same, but change the sign in the middle. And your numerator and denominator have to match because that's a 1, if you will. And then that will change how it looks. So when I do this, I have the limit as x approaches 0. Oops, I forgot before I started. I better have plugged the 0 in first. I have 0 over 1 minus 1 or 0. So now I can do this. This is an indeterminate form. Sorry, that's the first thing you should do. Now, when I actually multiply it, what looks nice is the numerator because that's what we use the conjugate for. So when I multiply the numerator, I have a radical x plus 1 times a radical x plus 1. That's just the x plus 1. And the middle disappears, and -1 times a positive 1 is -1. The denominator is ugly, and that's okay. Just leave it just like that. Do not multiply it out. It's just a big mess. Now, when I do that, I see, oh, look, thanks for playing. The positive 1 and the -1 can cancel out. So now I have the limit as x approaches 0 of x over x times radical x plus 1 plus 1. Now, as I look at this again, I say, wait a minute, this is a factor. I can divide these two to make a 1, or cancel, if you will. So I have the limit. Notice I keep writing this every time until I actually substitute in of radical x plus 1 plus 1. Now I see, can I substitute the 0 in there? And yes, you can. I have 1 over radical x plus 0 plus 1. And that's wrong. Let me erase that. The 0 goes in the actual x spot. I don't know what I was thinking. I always hate it when this happens on a video. So I've got radical 0 plus 1 plus 1. So that's 1 over 2, and that is my limit. So far we've done some factoring when we have indeterminate forms to find the limit. This last one was we rationalize the numerator. Now, if we go to number 4, which is on the back, now I have something we call, if you recall, called a complex fraction. So this one, not only is it a rational function, but it's a complex fraction. So the first thing I do is substitute the 0 in there to see if I can. So I get a 0. Then I got 1 over the square root of 9, which is 1/3 minus 1/3. So I still get the indeterminate form of 0 over 0. And then I look at it and say, wait a minute, I know how to get rid of a complex fraction or make it look different, is I'm going to multiply everything by the numerator, the common denominator of the numerator and the denominator. So I'm just going to erase this so you can see what I'm doing here. So I'm going to multiply everything, this is over 1, by 3 radical 9 plus h, 3 radical 9 plus h, 3 radical 9 plus h. When I do that, all right, I say, all right, this is going to be, okay, thanks for playing, the limit as h approaches 0 of 3 minus, thanks for playing, radical 9 plus h all over 3h radical 9 plus h. Now I know the numerator looks okay and the denominator looks really ugly. I get that, and it's okay. That's okay. But now I look at it and say, wait a minute, now we're back to what we had before. I bet you I can use a conjugate to get rid of the radical in the numerator, because right here, I'll show you in a minute after I write this down, that if I tried plugging a 0 here, I'm still going to get 0 over 0. So I have to keep doing something else, the algebra, to see if I can get this to work. So as I do this and multiply this out, again, the numerator is going to be a lot prettier than the denominator. I have the limit as h approaches 0 of 3 times 3 is 9 minus, now it's radical 9 plus h times radical 9 plus h. So that's just 9 plus h, but make sure you put it in parentheses all over this. Now this is the scary part, 3h radical 9 plus h. Then I use a bracket and say times 3 plus radical 9 plus h. Again, don't worry about multiplying it out and just leave it that way. Now when I go to do this, I said, oh, I've got to distribute that negative. So this is really 9 minus h, and I can say thanks for playing. So this is what I have so far. I have the limit as h approaches 0 of negative h all over 3h radical 9 plus h times 3 plus radical 9 plus h. Now, if I try plugging 0 in the h spots, again, look what happens. I still get 0 over 0, but then I notice this is a factor, even though it's a binomial. I can cancel out or divide those h's to make a 1. So this is the limit of negative 1 over 3 radical 9 plus h times 3 plus radical 9 plus h. Now I look and say, and I have to say as h approaches 0, now I have to say, can I plug the 0 in? And I see that I can. Once I plug the 0 in, just stop writing the word limit. So this is going to equal negative 1 over 3 times radical 9 plus 0 times 3 plus radical 9 plus 0, and that is negative 1 over 3 times 3, because that's the square root of 9, times 3 plus 3, or negative 1 over 9 times 6, or negative 1 over 54. So that one kind of had both of those. All right, the last one here is kind of a simple thing, and basically all you want to do is, if you want to find the constant case such that the limit exists, you want to try making sure it's in the indeterminate form 0 over 0. So I know if I plug a 2 in the denominator, I'm going to get a 0. So I'm going to basically plug a 2 in the numerator. I just put the 2 in front of the k, and make it equal to 0, because if this was 0 over 0, then the limit would exist. So now I do have 4 plus 2k minus 10 equals 0. 2k minus 6 equals 0. 2k equals 6. Divide by 2, k is 3. So now I know if k was 3, that would get the indeterminate form 0 over 0, and then the limit would exist in that spot. So that's all for this lab. Please make sure you watch videos 1 and 2 before you do this, because it'll make a lot more sense.